All right, let's look at this first think pair share. So the first thing is we need to notice that, yes, this is a second order equation. So this is a trinomial here. But the problem is that our leading coefficient is not equal to 1. It's a 7. So we're going to have to factor out this 7. And when we factor out a 7, we'll factor out a 7 out of each term. All right, so if we begin by factoring out a 7, then if we factor a 7 out of 7x squared, we're left with just x squared. And if we factor out a 7 out of 126x, then we get a negative 18x. And if we factor out a 7 from 315, then we get 45. All right, so now this trinomial is in the form that we require. It's second order, and the coefficient in front of this leading term is 1. So now what we can do is we can actually factor this trinomial. So we need two numbers that multiply to give us this constant term of 45, but add together to get us negative 18. So what could this be? Well, to get 45, let's see here, that could be 3 times 15, and that's 3 times 5, right? So we could have 3 times 15 or 9 times 5, right? Well, if we do 9 times 5, we could have a negative 9 times a negative 5. That would give us positive 45. That's only going to give us negative 14 when we add them together. Okay, so that's not going to work. But we could do 3 times 15 if we had negative 3 times negative 15. The negative 3 minus 15 would give us negative 18. So this is our j, and this is our k. So we're going to have 7 times x plus j times x plus k. So 7 times x, and now j is negative 3, so that's going to be minus 3, and k is negative 15, so that's going to be negative 15. So this is the factored form of this original trinomial. All right, let's look at this next think pair share. So in this think pair share, we already have a leading coefficient equal to 1, and both x and y are second power. So now we just have to look at negative 65 and look at factors of that. Well, let's see, factors of 65, it's just going to be 5 and 13. So 5 and 13 are both prime numbers. So what we need to look at is only one of these two being negative. So we're going to have like negative 5 and positive 13, or positive 5 and negative 13. And so between those two options, when we add them together, only these two are going to add together to give us negative 8. So this is our j, and this is our k. So the form this is going to take is going to be x plus jy times x plus ky. And j is positive 5, and k is negative 13. And this then is the factored form of this trinomial up above. All right. Let me know if you have any questions.